Is it working? Okay, good, it's working. Okay, hi everyone. I have a lot of explaining to do, but I am the scientist Taylor Simpson. I have been trying to broadcast for months, trying to get out to other scientists and the general rest of survivors who survived that horrible pollution catastrophe, all those who survived the 6th extinction. So, now what I'm here to do is, because everything has been destroyed and the science of biology has been entirely altered due to all of the pollution, and it's changed the way organisms have developed, how they've grown, all of this, how they're evolving. So I've just decided that I will, because I am a taxonomist, I'm a scientist who studies taxonomy, and for those of you who are watching or listening who don't know what taxonomy is, it's a field of science having to do with the classification of animals, so I am so glad I can get this broadcast up and working. Now, obviously there are more important things to do, but I just thought because taxonomy has been going on for so long, back since the days in ancient Greece with Aristotle, classifying organisms, we might as well start there. So I decided I'd go on and I wrote down some notes on the organisms I found, if I can find them. There. Okay, so I have all my notes on here. And first, just I'll give some information on the creatures, and I'll have a lot of my notes at the end of this broadcast, so you can examine them and critique them and do what you need with them. So first, I have the photosynthetic shark. Its binomial nomenclature, which binomial nomenclature is a two-part naming system. Typically, Latin or Greek words are used in it. Its binomial nomenclature is Photosharkist. It lives in the water, and it is a autotroph, and it is eaten by aquatic humans and the giant aqua spider, both of which I'll get onto later. It is 10 feet in length, 3 feet wide, and it is 5 feet tall. Now, the chemosynthetic goldfish. The binomial nomenclature is Chemogoldus, and it lives in the water. It is a autotroph, but whereas the previous organism got its food and energy through photosynthesis, this is a chemotroph, which means it gets its energy from chemicals, which in this case are from the pollution we have caused. Now, it lives in the water again, and it is a autotroph, and its predator is again the giant aqua spider. It is 8 feet long, 2 feet wide, and 3 feet tall. Now I have the aquatic humanoid. Binomial nomenclature Homo finis. It lives in the water, and it is a heterotroph. Now, it has kind of a mermaid-like tail, if you remember those old movies back like in 2015 and 2016, where they just have one big fin for a tail. They have a tail like that. And then they have fins kind of like a shark's, or what used to be a shark's. They're dorsal fins, but on the sides where we have arms. And it is a heterotroph, and it eats aquaweed and the aforementioned basking sharks. It is 2 feet in length, and by length I mean from shoulder to shoulder. It is 7 inches wide, and by that I mean like the width there. And then it is 6'4", so pretty tall. Now I have the aquatic wheat. It is called Photoweetus, and it lives in the water, and it is a autotroph, and it is 10 feet in length, and what you may consider height of it in the water, I consider length. And then it is 2 inches wide and 2 inches tall, which would be a lot like that on what the vines and cords of all of it are like. Now I have the terrestrial humanoid, which is called Proteria sapien. It lives on the land, and it is a heterotroph, eating butter roaches and fuzzy hamsters. It is 2 feet 2 inches in length, 3 inches wide, and it is 6'10", even taller than before. Now I have the tentacle aqua humanoid, or Homo tentaculus. It lives in the water and is a heterotroph, eating aquaweed, and it is 2 feet long and 2 feet wide, and it is 3 feet 6 inches tall. Now I have the cockroach, which I have renamed to Proteria decomposus. It lives on the land, and it is a heterotroph, eating our waste, so not much has changed with him or her. It's a cockroach, so I'll go with either one. And it is 2 inches long, 1 inch wide, and 2 centimeters tall. Next, we have the giant aqua spider. Horrible, horrible creature. Just kill it if you see it. And I named it Gargantuous octolegus. If I could have given it a different name, it would have been Killis with Virus. Now it lives in the water, and it is a heterotroph, eating the chemosynthetic goldfish and basking sharks. Now it is not called giant for nothing. It is 20 feet long, 18 feet wide, and 8 feet tall, so even if I wanted to, I couldn't fit it in this bunker, even with how much space I have in here, so. Next, we have the green-haired rat, called Furus ratus. It lives on the land and is a autotroph, because the green fur is due to chlorophyll for photosynthesis. It is eaten by 10-legged fleas, which by that I mean they're parasites living on the green-haired rats. They don't actually go around eating full-sized rats, which are 1 foot in length, 3 inches wide, and then 2 inches in height. Next we have the parasitic mosquito, or Parasitus wingus. It lives on the land, and it is a heterotroph, and it is a parasite, as already mentioned, and it preys on any humanoid, but it, again, is a parasite. It will not eat you whole or anything crazy like that. Now it is 5 centimeters long, half a centimeter wide, and a centimeter tall. Next we have the 10-legged flea, or Parasitus decalegus. It lives on the land and is a heterotroph, preying on green-haired rats. It is 2 centimeters long, half a centimeter wide, and 1 centimeter in height. Next, we have the poison grass, which we believe to be a mixture of poison ivy and normal grass. We call it Toxicus grassis, and it's on the land, and it is a autotroph eaten by butter roaches. Nothing else, though, can't even touch it how toxic it is. And it is half an inch in length and width and 2 inches high, and I am talking about the blades of grass, not the vines it's on. Next up we have the fuzzy hamster, believed to be related to the green-haired rat. Its name is Furus petis. It lives on the land, and it is a autotroph, again because of the green fur. It is eaten by terrestrial humanoids. It is 6 inches in length, 2 inches wide, and 2 inches tall. Last but not least, we have the butter roach, or Proteria geneticis. We actually genetically engineered this by combining the DNA of a butterfly and a cockroach. I don't know why we did that, we just thought it was a good idea at the time. And it lives on the land and is a heterotroph. It is eaten by terrestrial humanoids, and it eats poison grass. Now it is 6 inches long, 4 inches wide, and 1 inch in height. And now I have some charts I need to show you, which I will also for you to have closer examination. For those scientists out there, I will have pictures of these charts put at the end of this broadcast. Now, first thing, we have this chart up here breaks down how I classified all of these, going from kingdom, from life to kingdom to phylum to genus to species. Here I have under what terms I classified them, and then here you may see the numbers and then the names seen up here. Well, before I had any names, I had to go by their number of the order I found them, so I had to do that before I could do this. Next up, we have actual images of these creatures. So, here you have them: the 10-legged flea, the cockroach, the parasitic mosquito, chemosynthetic goldfish, the basking shark or photosynthetic shark, terrestrial humanoid, aquatic humanoid, butter roach, green-haired rat, fuzzy hamster, tentacle aqua humanoid. See why it was so wide and so short? We don't know how it became octopus-like, but it did. The giant aqua spider, the aquaweed, and the poison grass. There you see the blades on a vine with vines sprouting off of it. Next up, I have created a dichotomous key of how to classify all of these things if you find them and don't know what they are. Again, I will put a better image of this at the end of the broadcast. And then finally, I made a food web showing interactions of how energy is transferred through our now mostly broken food chains. All starting with the sun, and then it travels through many organisms, but not all of the organisms I have mentioned. So, yeah, that's all I can really show. My time's running out. I need to get back to work, so I hopefully will see you later.